To start working with our sprite sheets on the canvas, the first thing we will need to do is to bring the images, the image files, into our project so we have access to them. Currently we've been loading the background image and the face image. So I have added the files to my assets folder, and now I'm going to start adding them to the project. So the easiest way is just to copy one of these, and I'm going to add the smoke, the unicorn, and the wolf. So we'll do one of each, and then we'll kind of decide how we want to work with those. So now we'll have our smoke image, our unicorn image, and finally a wolf image. And now I can just copy that, and I should have alt-clicked on those other two when I did it, so I could have just typed once, but I forgot to do that. So Alt or Option click, paste, so that speeds it up. Now what we have to do with this, that means 3 more images. So our total assets that we're loading, 1, 2, 3, 4, 5. Change our asset count. Whoa, that was crazy. To 5. Finally, what we have to do is on these new images that we made, we have to make sure to identify the size that's going to be. So if I look at the smoke here, I can see that down here it's 2400 by 2400 in size. So if I go back into my project, smoke image, 2400, 2400. We don't put these sizes in. It still works, but it's better because then the compilers, or not the compiler, but the renderer is able to then allocate the correct amount of memory while it's working with it. Now if I look at the unicorn, we'll start with the small one right now and see that is 192 by 256. So now we'll go into the unicorn, and it's 192, 256. And finally, if I go on to the wolf, and I'm going to go for the slow big wolf, so that is going to be 1536 square. All right, that works. So 1536, 1536, and now I just need to update my URLs. So, oh wow, typing is proving challenging this morning. That doesn't bode well. And we'll just do the base unicorn, and then the wolf is going to be wolf left slow big. Okay, and not wolf left, but wolf. All right, gotta make sure we spell it correctly. Copy paste from the actual file names if you find your typing is going to be difficult for you. But now we've loaded those assets, we've made them part of it. We're not displaying them yet, but we will be shortly. Now the next thing that I want to do is to create a class for my different sprites as I'm going to work with them so that I can then display the sprite sheet. Now there's a couple of things that we're going to realize as we do this. We're going to be creating, in the beginning right now, 3 separate image classes, one for each sprite sheet, because they are going to move or animate differently on the screen. But it would be possible down the road as we could create a master sprite class, because the display portion of it, the constructor portion, all of these things are going to be pretty similar. So it would actually be nice to just have a master class that we just send to it the unique kind of properties or values that we're working with, and have more of a template class, or then even inheritance between classes. So we'd have the master class, and then we would have child classes that behave with their own unique properties. So that would be a way that we could do it. But right now, because our classes aren't that big, and to keep things simple, we're just going to be repeating what we're working on. So our Spritesheet class is going to be very similar to what we did with the head class prior. So I'll just copy that, paste it. So now I'm going to just start out with the smoke. And now when I'm going to create the smoke, we can pass in an X and Y with it. Now the smoke, right now, it's not going to go anywhere. So I'm just going to comment those things out. And then all of this information here, I'm just going to comment that out because the smoke is going to just be parked. I'm just going to put it on the screen so it's just there. Now, when we start drawing it, this is where it gets a little bit different as we work with it, because we need to specify one that we're now working with the smoke image, which, let's see, what did we call it? Smoke image, just making sure. And if we did that, we could now put it on the screen. But what we want to do is we don't want to display the whole image. So we're I'm gonna do this in pieces with it so we can see what's going on. So if I just simply say let smoke, lowercase smoke, equal a new capital smoke. And now this time going to put the smoke, let's say I want to put it over at 500, and I'm going to put it at 100 down. Let's see how that looks. Save it, and let's see if anything happens. And nothing happened, of course, because we didn't say smoke.display. Now let's see what it looks like. And there's the smoke faintly showing up on screen. So we're kind of seeing it because the smoke is translucent. I think I do want it a little bit higher, and I'm going to move the left over just to 100 so it shows better on the blue instead of the color. So we can see there's some smoke there. We see when the face is going behind it, but it's not animating, and it's showing us all of it. This would almost, I think, be easier. We're going to go and make another class here. This time I'm going to work on the unicorn. And the unicorn that I want to load, I'm going to actually load the horizontal one first. Actually, well, it doesn't matter which one I load, but we're going to load the unicorn. And the unicorn, I'm going to park it for now. And we can just leave that. Actually, well, we don't need to. It doesn't really matter on these. If we don't call update, then it doesn't matter. But I want to show the whole unicorn because the smoke is so transparent, it's kind of hard to see what I want to convey. So let unicorn equal a new unicorn. And we'll put the unicorn at, well, why not? We'll put it at 100 and 400. And then right down here, it just won't call update, so it won't move. Now let's see. Okay, so there's the sprite sheet. But I only want to show one frame of the unicorn. I don't want to show all of it. So we want to create a window. And the way that we can create a window is to use the additional properties that are present when we choose draw image. So when we choose draw image, what we're able to do is we can choose the image that we want to draw, or the texture. And then we have a bunch of other properties, not just where we're going to draw it. So I'm going to write those properties out, then we will actually start defining them in the code. So what we are going to do is do our source x, and well, we might as well do it properly here. We have to use this source x, this dot source y, and then this dot source width, this dot source height, and then we have 4 properties, which you might realize, of x and y, but also this dot sprite width, this dot sprite height. So we have more properties when we use draw image beyond just the texture in an x and y. So this allows us to choose a window of where we're trying to do it. So now I need to define out these additional values that are here. So this will be not sprite, but sprite vars, and it'll be this dot source x, and source x, well, we're going to start it out at 0. This dot source y is going to start out at 0 because top left corner of our sprite sheet. And now this dot source width is going to be the width of a sprite. And now if we remember on our unicorn here, unicorn is 192 wide, so then we're looking at 64 wide, and I don't remember what the height is. So these are 64 square. So if we're going to work with 64 squares, so we just do 64. This dot source height is going to be 64. And right now we're displaying it at the same size. Source, or not source, now we're on sprite, because we have the x and y's. Now we do sprite width is going to be equal to 64, because it's possible in our sprite sheet that we have larger or smaller artwork and we want to scale it when we put it on screen. So it's possible that these numbers won't be the same depending on our sprite sheet when we bring it in. We may have a sprite sheet that's much larger and then we scale it down, or we scale it up, and we can play with that here in just a minute. So now if I save this, let's see, and I only get one sprite. Now if I take my source width, and just for fun, let's go 128, let's see what I get. We can see now it's showing me 2 frames, but it's squishing them horizontally because we said, well, the width is that. So what we're trying to see here is it's a window. So if I were to even just do something like 150, and we'll change this to 150 so we can see all of what's there, save that, we'll see we're getting part of it. It's given us a window into the sprite here. So that's why when we use the sprite sheet, we can define that window that we're looking at, and now that gives us a single frame. The next thing we have to do is animate it. So we have to figure out how can we update it or animate its information. So I'm going to stop the movement on it. So I'm just going to comment out those lines. So when I call update, it's not going to move because I don't want it to move just yet. Now I need to add a couple more items here for my sprite, and I need to store our current frame. So we have to know what frame we're on. So current frame will start out at 0. In this case, the unicorn has 10 frames. So we need to know the frames that we're working with. Then I also need to know how many columns are in this. And the reason we're doing this and storing it as a variable, then I can just pretty much copy paste this into any sprite class I'm working on and just change the number of columns to match my sprite sheet. Here we look and it's 3 columns, and we don't care how many rows. Well, as I visually looked at the rows, I'm like, there's 4 rows, so I'll type in a 4, even though I'm trying to type in 3 because it's the columns. All right, so now what I need to do is I need to update current frame. So I need to say this dot current frame is going to be equal to, and we have a couple of different ways that we can do this. One way is that we can just update it by saying this dot current frame plus plus, and then I can go if this dot current frame is equal to total frames. Oh, forgot. We need one more variable up here. This dot total frames, and the unicorn, when we look at the unicorn, is 10. I always like to verify that and don't just go by memory and get it wrong. Total frames. Oh, gotta rewrite it. Total frames. There we go. Code completion is my friend. And don't need that extra paren there. Now curly brace. And so if my current frame is equal to the total number of frames, because our frames start counting at 0, 1, 2, 3, 4, 5, 6, 7, 8, and then if it becomes 9, and then it becomes 10, 10 is too many, so then we go current frame is, we'll just set it back equal to 0. And we can see, you know, what this dot. So that's one way to write it. My preferred way of writing it uses the modulus math operations. We use the modulo operator, and what that does is it does long division, but we only keep a remainder, and that allows us to just create a repeating number loop, and it just is a cleaner way of writing it. So instead we'll say this dot current frame is going to be equal to this dot current frame plus 1, and then we do the modulus math operation, which is represented by the percent sign, this dot total frames. So the math that's happening here is we say the current frame was 0, and then we say we're going to set current frame equal to current frame plus 1, so that's 1 divided by the total number of frames, that's 10. 1 divided by 10 is 0 with a remainder of 1, so now it becomes 1. The next time through, current frame plus 1, so now that's 2. 2 divided by the total number of frames is 0, remainder of 2. Now we keep on going until we do current frame plus 1, 10. 10 divided by 10 is going to be 1 with a remainder of 0. And because we're only keeping that remainder, we're now back to 0. So it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3. And it creates a repeating number loop. So the modulus sign is your friend when you are doing sprite animation, game programming, and all kinds of things like that. So a friend of mine who is a financial officer at a major corporation said, why do our kids need to learn long division? They just always use decimals in the math calculations that they're doing. And I said, I know why. Because sometimes you need it when you're doing game and visual programming, because we use the long division and keep the remainder. We don't care what the actual operand returns. We just want the remainder because it gives us an infinite repeating loop. So I was able to point out there is still some reason why we might want to understand and keep long division as part of what we learn in our math courses. We don't use it often, but it can come in handy. All right, so this now updates current frame there. That's sweet. And now the next thing that we need to do is we need to change the source X and the source Y, because if we look at where the visual was, so if I take the source X and we're just going to go over from here, so if I go over, let's say 32, now if we look at it, we'll see I get half an animal, front half and back half. So, well, that's silly. That's not working out really well. So we want to go over 64. And we want to adjust it. So we keep moving the X over 64 until it is far enough over. And this is where our columns are going to come in handy. This is where the columns are going to become our friend. So this dot source X is going to be set equal to, and in this case now it will be this dot current frame, and then we're going to divide it by the number of columns, and then we're going to take that value. So we take the current frame, divide it by the number of columns, keeping the remainder of that operation. So that remainder is going to be, so the current frame, so if we take 0 divided by the number of columns, well, then it doesn't really matter. We divide it by 3 and it gives us a remainder of 0. And then we multiply that by this dot sprite width. Remember, X always talks about width values, and Y will be talking about height values. So now let's just continue that thought experiment here. So now, if the current frame becomes 1 divided by the number of columns, which is 3, gives me 0, remainder 1 times the width of the sprite, change source X to 64. Then, when our current frame is 2 divided by the number of columns will be 0, remainder 2. That gives me, now we bump over one more column. Now 3, when current frame is 3 divided by the number of columns, which is 3, is 1, remainder of 0, so 0 times sprite width will give me 0. So remember, we want 0, 1, 2. So when current frame is 3, so let's see, there's the first frame, second frame, third, so 0, 1, 2, 3. So when current frame is 3, then we're back to 0, because we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are how we number our frames. So we go 0, 1, 2, 3, 4, 5, 6, 7, 8. And remember, that's how we get our math, because 0 divided by 3, 0, remainder 0, right there. And then 1 divided by 3, remainder of 1. 2 divided by 3 gives me the remainder of 2. 3 divided by 3 gives me a remainder of 0. We're now back over here. And 4 divided by 3 gives me 1, remainder of 1. 5 divided by 3 gives me 1, remainder 2. So that's how we end up using this to move ourselves across our animation. So let's save this and see what happens. Nothing's going to happen yet, because let's go down here before we display the unicorn. Dot update. Now let's see, do we have, and now we can see we're doing 3 frame, so it's doing just those frames really flipping fast. So yeah, we need a few more frames in here to kind of slow it down. So let's go through and go this dot source y is going to be equal to, and this time we will just do division. But we need to, because our division won't always come out even, we need to do a little bit of math here, and we are going to round down so that we're always getting whole pixel numbers. And then we take our current frame, and we are going to divide it by the number of columns. So instead of keeping the remainder, this time we are going to just take the current frame, divide by the number of columns, because that's going to tell us what we want our row to be. So when current frame is 0, 1, or 2 divided by the number of columns, so 0 divided by 3 gives me 0, times that by the sprite height, and times this dot sprite height. So when it's 1, current frame is 1 divided by the number of columns, that's 0.3, we round that down, that's 0. So again, it keeps us in that first row. But when current frame is 3, when current frame is 3, 4, or 5 divided by the number of columns, that's going to round down to 1. So 1 times the sprite height, that now puts me down a row in my sprite sheet, puts me down a row. So 0, 1, 2, 3, 4, 5. Now when it's 6, 7, or 8, 6 divided by 3 is 2. 7 divided by 3 is, well, it's a little bit more than 2. That rounds down to 2. 8 divided by 3 still rounds down to 2. 9 divided by 3 is 3. So that's how we're able to go 0, 1, 2, 3. So then that gives us a value of 3. 3 times 64 gives us the correct source y. So now we're able to see that we have all of the frames of our unicorn animating and moving through here. Pretty awesome. The good part is now that we have that, we can recycle this, and just in the interest of space, I'm going to get rid of a few things, and I'm going to let the unicorn have a speed X so it can now update. And now let's watch what happens, and we can see our unicorn is now happily walking across the screen. We've successfully animated a sprite. With that happening, I'm going to take this class that I have here, and I'm going to duplicate it, and then I will change the movement, because the wolf is going left, so instead of adding speed X, I'm going to subtract speed X. And then we have to check for, or I can just set my speed X equal to 0. That's probably even better. Or I mean a negative value. And then instead of going to canvas width, we want to be less than 0. So we have to go the opposite way if we're going to do that wrapping. So we'll take a look at that now. So let's go grab this whole class, copy it, paste, and now this time this will be my wolf. And we'll just give speed X a negative value. And now if speed X is less than a negative amount, and I don't remember how big it is, so let's pull up the sheet for that. So if we go, I'm going to go with the slow big wolf, and this is 1536 on it, and that means 384. So we need to be less than 384. That will put it fully off screen. Then we would put it at the canvas width. We're not going to be moving on a height value. Now we just need to update a few of those values. So 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 rows. So it's 192 tall. So the sprite height is 192. Source height 192. And maybe this time we'll change the sprite height around after we've verified it worked. And so the 1536 divided by 4 is 384. Oh, yeah, I had my number there and totally forgot to already look for it. I was like, I got to do math again. That's hard. Okay, source width, oh, sorry, 192. And then this is the 384. So the width is 384, height is 192. And columns on the wall, it is 4 columns. And so 1, 2, 3, 4, 5, 6, 7, so 28. So 30 frames. So we'll put in 30 frames for the wolf here. And this time we're not going to draw the unicorn image, we'll draw the wolf image. All right. Now, the Y part, it's not doing anything because we're not animating on the Y, so we'll just cross that out or comment it out. And now let's go here and say let wolf equal a new wolf. And I'll draw this over at 700. Actually, we'll start it completely off screen. And I'll just put it down at 100 for now. Let's see what happens. We can always adjust all those values once we get it moving on screen. And there is the wolf. All right, so based on the wolf's size, we might want to modify the speed a little bit here. So remember, we have to have our classes first before we try and instantiate them, because if the class appears below this, then that causes hoisting and it gets grumpy with us, so that doesn't work really well on it. So I'm just going to do one thing here. We saw how it looked really big. And now if we shrink this down, we'll see how, okay, we got a few issues going on there. And I realized before, when we had equal sizes, like on the unicorn, I kind of goofed a little bit here on my update. It shouldn't be my sprite width here, it should be my source width and my source height. When we leave them the same, when source width and height and sprite width and height are the same, then it works. But now, so yeah, let's go fix that in the unicorn so we don't perpetuate. So that's why it looked really weird, because when I used the sprite, when I made the sprite size half the size of the source height, that's why it gave that weird ghosting. It wasn't getting the right information. So our source X and Y, yeah. Oh, need an S. Source X and source height. All right, now they both should be fine. And apparently, because, well, speed is random, yeah, that's not working really well. Under that, we got a really unfortunate speed. Now I got a really fast speed. So maybe we're just going to, let's just do a fixed speed and see. I'm going to slow it down and maybe do 3. Okay, that's a little bit better. Now, our frame rate is smoking on these. So if we don't have enough frames in the animation, we need to slow it down. We can slow down the whole sketch, or we can do a more complex per sprite slowdown as well. So we could slow down how frequently it updates itself to create an effective slower frame rate. Ideally, you bring in the frame rate, your Spritesheet matching the frame rate of what you're planning to use, and that's going to work a little bit better. But we will look at a strategy of how we can manage our frame rate. But what I want to do now, since we started with the smoke and really didn't do much with it, I'm going to redo the smoke, adding in the values that we need. Actually, since we have the whole class, we can just we'll just copy the update and the part of the display that we need. So if we go into smoke here, let me just make, okay, there's smoke. Paste that in, and now we just need to go and grab some values that we will be using. Source XY with height, columns, frames. Copy that. Go into the smoke. Paste that in. Now, if I go find, let's go get our smoke thing. So this was 48 frames, 2400 wide. So it's 4 rows of 12. So again, it's 200 wide. So the source width is going to be 200. We'll start out a sprite width of 200. And our height was 600. 48 frames. And it is 12 columns for the smoke. Now we have, well, corrected this with the source, and source wise, and now we just need to change this back to smoke image. Now let's see what we get here. And the smoke, one thing we never called on smoke, we never told the smoke once it was on screen. Smoke, update yourself. Now we can see there's the smoke. Now I think I'm going to move the smoke over here, maybe make it look like the smoke is coming out of the mouth. So let's go, maybe try and put it at 500. So now it's kind of coming out of my neck. It's kind of fun. We can leave it there. So we have now successfully animated 3 separate sprites. And we can see how the logic of doing so, once they're in classes, it gets pretty clean inside our draw function. So our next thing that we're going to look at is how we can change the frame rate of our canvas animation. So we'll modify that so we don't have some of these super speedy animations, but we're going to just start out right now with a global speed change, not a complete overhaul where we have to make each sprite animate at its own rate. But that is another feature that we could look at. Next piece in our puzzle is we're going to control time. So to be able to do that, we're going to create a couple new variables. So I'm going in right after assets loaded because this is where we're going to use it. And I'm going to set my frames per second. The default will be 60, which should be pretty close to what we're currently doing. And then we're going to create a frames per second interval. And that will be equal to 1000 divided by my frames per second. So what we're doing is we're setting it so all I have to do is just change this number, and that is going to then update the playback of my project. Then I'm going to set my current time equal to 0. And then we'll let my start time be equal to that actual current time and date right now. Now we get to make a new function. This function will be called control time. And with that, what we're going to do is now say current time is date.now. So what that does is that grabs the current time in milliseconds. And the next thing is I'm going to calculate how much time has passed. And that will be my elapsed time. And that will be simply equal to my current time minus my starting time. So we generated start time, and then we updated current time, and then we take current time and subtract start time from it. Now we say if my elapsed time is greater than my frames per second interval, then what we're going to do is call our draw function. And then we will take and say our starting time is now going to be equal to our current time. So remembering when this function happened, we reset current time to what the current time is. And then if a correct amount of elapsed time has passed, so current time minus start time, then we're going to update our starting time from its original value to the current time. So this just creates a loop. Finally, this is now where we will call request animation frame, and instead of calling draw, we will call control time. Now, we need to do two more changes to update this, and then we will see it taking effect. The first is that we no longer inside our draw function will call request animation frame. Second, our assets loaded method that was calling draw is now going to call control time. And that is it. So we don't really see any change going on there, but if I knock this down, let's knock it down to 24, we'll see that suddenly everything is going a whole lot slower and more manageable. So that is all it takes to regain control of the playback. Now, if I were to put in something like frames per second of 200, we'll see that, and well, that's going to be close to 60. So it doesn't speed it up beyond 60, because 60 frames per second is what it tries to maintain the whole time. But it is possible that we can slow it down to make it more manageable. So doing this is a recommended practice, even if we jump over onto MDM's website and look up using Canvas, we'll see that it does that. Now, something else you might look at is applying some of these filter effects to your canvas. So we'll see that we have some different effects. We have blur, brightness, contrast, drop, shadow, grayscale, hue rotation, invert. So you can see we have a number of effects, filters that we can apply to the canvas. And we can apply these to an element or to everything on screen. So just to show how that works. So if I were to say go and after head 2, we'll say context dot filter, and is it equal or percent? Oh, it's an equal, equals blur. Okay, I always want it to be inside our parens. So in a quote mark, blur 4 pixels. Now let's see how that looks. Let's jump over into my canvas. We can see that it's blurring everything. So if we say a filter and apply it and do nothing else, it applies to everything on screen. But if we just apply it to something and then we undo it, so now if we say our blur is 0 pixels, now what we'll see is only that one element has the blur applied to it. So when you're applying filters, you have to apply them and then effectively unapply them so that they're no longer being done. or we can say filter none as well if we're only, so it's filter none in quotes. Now, if we say none, that if we're only using one filter, that's great. If we're using multiple filters, then we do need to come up with other ways to undo it. But we can see how now that is applying a single effect. So just a little bonus beyond our time shifting, where we can control the time, we can also use filters in our projects.